Hello! Thanks for the feedback on the last question I did, which was additive persistence, and today we are going to tackle a problem about the triangle inequality. So, a right-angled triangle has positive side lengths A, B, and C, where C is the hypotenuse of the triangle. Using the Pythagorean theorem, show that C is less than A plus B. Then the perimeter of the triangle is P. Show that 2C is less than P is less than 3C, and you may want to use the previous part here, might be quite useful. And then we have a triangle that has positive side lengths x, y, z and non-zero area. However, notice that we don't necessarily have the hypotenuse here, and it isn't right-angled. So we're going to have to think about something a bit different there, and show that z is less than x plus y. Alright, let's start. Well, first, it would help to get an intuition about why this inequality is true, why we have c is less than a plus b. Well, let's consider drawing a triangle. It's right-angled, of course, and we have A, B, and C. Why do we need A plus B to be greater than C? Well, if we had A plus B equals C, so we had C here, then maybe A here and B here. If we sort of try and make this into a triangle, if we sort of like curve back the A and the B, we end up with C here. They end up like a curve here and like a curve here, and it just doesn't stretch to actually fit into a proper triangle. And in fact, this is why it doesn't work. The only sort of triangle we can make is just a flat line. It's not really a triangle, is it? Well, using the Pythagorean theorem means that we just have c squared equals a squared plus b squared. And this already looks quite similar to what we actually want to get. So we've got an inequality sign here, and it isn't squared. Like if we try and square root directly, we end up with like square root of a squared plus b squared, which doesn't quite square root down into what we want, and the equals wouldn't be right anyway. Let's consider a plus b squared, so all squared. Well, this is a squared plus b squared plus 2ab. So that means we can express c squared as a plus b squared minus 2ab to cancel out this term here. And because of that, well, a is positive and b is positive, so overall this must be negative. So in fact, we can safely say that c squared is less than a plus b squared. And actually, if we square root both sides, we get exactly what we want. Okay, the perimeter of the triangle is P, and well, the perimeter of a triangle, A, B, C with the right angle, well, that's clearly just A plus B plus C. And because of that, we want to, we have A plus B plus C. And since we use this inequality here, C is less than A plus B. So this overall here means that this A plus B is greater than a C. So it's greater than C plus C, which is actually just 2C. So that gets our lower bound that we want here already. Now we want the upper bound. Well, we know that C is the longest side, so that must mean that A and B can be at most C. So let's try and make a triangle where we have C, C, and C. Well, that's an equilateral triangle. However, the angles must be 60 degrees here. So we can't quite have this triangle because it doesn't give us a right angle, but we can get pretty close, and that's why it's bounded by 3C. Well, this part is more awkward. We have a triangle. We don't necessarily know the which labels are where, but let's, for example, call this one Z, this one X, this one Y, and these could be any angle, of course. Well, one thing we do know is the cosine rule. And you may notice that z squared is equal to x squared plus y squared minus 2xy cos of z, and I mean there's like capital Z here. I'll do a little dash here to make it more obvious. Well, again, if we use the same tactic as before, we can exchange x squared plus y squared for x plus y all squared minus 2xy, and then minus 2xy cos of this angle z, and that is still equal to z squared. Then we can combine this term, so we have x plus y squared minus 2xy and all brackets 1 plus cos of z. Okay, so, well, what are the possible values of cos z here? Well, we're using a triangle, and it has non-zero area, and we know that all the angles in a triangle must sum to 180. Alright, and because of that, we know that any individual angle, so z here, must be between 0 to 180. Like, it can't be exactly 0, and it can't be exactly 180, because then again, we get like the line that we had before, which isn't quite what we want. And considering the graph of cos z, well, it starts at 1 and then goes down at 90 and then starts coming back up at 180. And the lowest it can go is minus 1, and that's at 180 degrees, and the highest it is 1, and that's at 0 degrees. We know that x is positive, we know that y is positive, and this 1 plus cos z, because this is always less than 180, this is also positive. So this entire expression is negative, and that means that it is less than x plus y whole squared, which again means that z is less than x plus y.